right, let's talk about the hard angular projectile problems, aka the fabulous Zacchini worksheet. As you can see as written here, you should definitely do the cannonball problems first. You need those intro before you attempt these. These are quite a bit more difficult. However, if you feel like if you can do these, then you know that you're in really, really good shape for the upcoming test. Okay, so equation-wise, we've got our horizontal equation, we've got our vertical equations, and then of course we've got our trig and our Pythagorean theorem. All of that is available for us to use. What makes these problems difficult in one sense is that they don't walk you through what to do. And so I find it really, really helpful to draw a picture. It is not required for this, but I definitely would suggest it just so you have an idea of what's going on. So in this one, we've got Emmanuel Zacchini, number 1 is what we are on, firing out of a cannon with a speed of 24 meters per second and an angle of 45 degrees to the horizontal. Okay, so we know he has a 45-degree angle. We know that he is moving initially at 24 meters per second, and then they tell us he lands in a net 56.6 meters away from where he was fired. So we actually also know delta x, right? Okay, and then we want to know how long was Zacchini in the air. So delta t is our question. Okay, so step 1 is going to be to find Vx and Vyi because we have to have those in order to solve for anything, right? Okay, so we're going to treat the 24 as our hypotenuse. We've got a 45-degree angle, and then we need to solve for Vx and Vyi. Okay, we're going to use sine and cosine to do that. So for Vx, I'm going to choose cosine because that's my adjacent sides. I have cosine 45 degrees equals unknown Vx over 24. I multiply 24 by both sides to get it off the bottom. And 24 times cosine 45 gives me a Vx of 16.97 meters per second. So the nice thing about a 45-degree angle is that both sides are 45, or both angles are 45 degrees, which means both sides have to be the same. So I actually don't have to solve for Vyi. That's just a nice little trick from geometry that I want to use for sure. Okay, next I'm going to make my XY chart. Okay, so I happen to know that Vx is that 16.97. I'll give myself a little more space here. Okay, so I've got Vx equals 16.97. I've got delta x equals 56.6. I would suggest putting in units, but if you didn't leave yourself enough space like I did, you can drop them. Vyi is 16.97 also, which means Vyf is a negative 16.97 based on symmetry. I know Vy at the peak is 0, and I know A is negative 9.8 meters per second squared. Okay, so thinking about time, how long was Zacchini in the air, I actually could use either side of my chart. I've got a ton of information here. So what I'm going to choose is to use the x side because it's just a simpler equation. Okay, so Vx equals delta x over delta t. I'm going to manipulate that a little bit. I'm going to switch places like I do when I'm solving for the bottom. So I have delta t equals delta x over Vx. And so I can plug in my 56.6 meters over positive 16.97 meters per second and get a delta t of 3.34 seconds. If you should happen to use the y side, you should get approximately the same time, and either way is really fine. Okay, so all of these problems are going to be similar to this. There are only 4, so I don't want to work another one out for you, but reach out to your teacher if you've got questions, and on every single one, start by drawing yourself a picture and then and do that t-chart to figure out what do I know on the horizontal or x side and what do I know on the vertical side.